What is up, guys? How you guys doing? In this video, we're doing something very interesting. We're going to be using Postgres with Golang. Now, I've received a lot of requests and a lot of comments on my YouTube channel asking me how to use Postgres with Golang, and I wanted to show this to you in the best way possible, or the easiest way possible at least. So the easiest way that I think to use Postgres with Golang is using GORM, right? So you want to interact with the server, Golang server, with Postgres, and the easiest way to do that would be using GORM. And also, there's a video on my channel, the MySQL with Golang video, right? And that has become really popular. It's gotten around 18,000 or 20,000 views or something like that. So what I'll be doing is I'll be using a very similar code that I've used there, in the sense that we'll be using GORM just like we've done in the MySQL video, and we'll be using exact similar kind of APIs, as in we'll be working with the books API, right? So we'll have a struct called books, and we'll be working with books APIs. At the same time, we'll also use Fiber. So that's something new that I'll be adding to the mix. Like in that, I think the MySQL video, we used something else. We used probably Mux or something like that. Here, I'll use Fiber. So in essentially, what you're learning here is you're learning how to use Golang with Postgres, but also with the help of Fiber. So how do you use all these three things together? Now, I'm not sure if I'll be able to complete this in one video because I'm slightly pressed for time. I mean, I have a few tasks to get done after this. So I might have to break it down into 3 small videos. I'll have to take breaks, and but tomorrow I'll have to upload the second part and third part and so on. So this may be divided into small parts, but those parts will be like 3 or 4, not more than 3 or 4 parts, because this is not a big project. It's a small project. Just want to show you by building a simple REST API. I just want to show you how to use Postgres with Golang. Nothing complicated out here. Not a big project. Max 3 to 4 small videos. I would have done it in one video. That's what I wanted to do, but I'm just really pressed on time, so I'll have to shoot tomorrow instead. Anyhow, now let's start with the project. So firstly, we have to create a directory called go fiber Postgres, and we'll cd into it. Then we'll say go mod init, and whatever name you want to give to this project. I'll obviously give github.com and /my name, and the name of the project, which is go fiber Postgres. Now, go mod init works like npm init, where it creates a go.mod file for you, which is the equivalent of package.json file in Node.js. Right, so a lot of people who are learning Golang come from a JavaScript background, so I try to inform them this command is like npm init basically. And with Golang, you give these absolute paths, right? So we don't have like an npm kind of a scene here in Golang. So whatever even the packages that you create, you have to host them on GitHub. And this is how when you import packages, the third-party packages, you don't have like an npm. You import packages that look like these kind of links. Okay. Anyhow, so what this means is that this would have created a go.mod file for us, which will have the list of all the dependencies that we'll be using in this project, all the external dependencies. And I'll open up this folder in my VS Code. You could be using anything else, but VS Code is the one that I prefer usually. And a couple of extensions I'm using. So if you go to your VS Code and you type Golang, the first 2 or 3 extensions that come up, I use them usually, the first 2 at least. So let me install this in WSL. Yeah, that'll keep happening on the side. Now it's asking me to install this in WSL because I am using Windows, and I'm using something called as WSL on top of Windows. Actually, it's a part of Windows. WSL is a part of Windows, but WSL allows you to use Ubuntu inside of Windows and multiple Ubuntu instances. So it works for me because I have to work with different versions of Ubuntu for different type of projects, right? So just install the first 2 Golang extensions that come up. It's just going to help you to fix code, in the sense it'll give you those squiggly lines whenever there are issues and that kind of stuff. In my earlier videos on YouTube, I have not used any extensions, and that's because, and I stick by that. I say that as much as possible, try avoid the use of extensions, because when you are called for coding interviews, you're not allowed to use your preferred or favorite, you know, what do you call it, IDE, your preferred IDE. You know, they'll probably have just a window with a screen shared with the interviewer, and there'll be their own built-in IDE in their app that they'll use. And that's where a lot of people that I mentored, they get into a lot of trouble there because they're so used to working with all these extensions. So I'm just using them here because a lot of people have told me, well, use extensions that will be just better for the viewers. I'm just using it for the viewer. Otherwise, if you're a programmer, if you want to get serious about programming, I would suggest don't use extensions. So out here, the first folder that I'll create will be models. Then I'll create a storage folder. And then you'll just create your env file. And you'll create your main.go file. So main.go file, as you know, is the most important file in a Golang project. And what we can do is we can start working with the main.go file. So the main.go file, what you're going to say here is you're going to say package main. You'll import a few packages. We'll talk about that in a minute. And so the most important thing that you'll do here is basically your func main. So you'll come here and say func main. And we need the .env file to be imported. So we'll say go .env, which is our env package. We'll import it shortly. And we'll import the .env file. Okay. And when you run a function like this, you ideally want to capture the error and handle the error out here. So we'll say error is not equal to nil. You want to say log.fatal error. Okay. Now, what you want to do is you want to say app is equal to fiber.new. That means, like I told you, we'll be using the fiber package to create these routes. And a lot of people coming from a JavaScript background, they really like using fiber. And the reason is that it works in a very similar syntax to Express. And the inspiration for fiber is Express. Only fiber is, I think they say it's 10x faster than Express or something like that. It's just, it looks very similar while using it, but it's like way faster than Express, right? The whole Express and Node.js platform. This is Golang is obviously way faster. And but what you do is you create this variable called app, and you say r.setup routes, which is a function that we'll create right now, and we'll send app to it. And then you can say app.listen, very similar to Node.js, right? On 8080. Okay. So the setup routes is not a simple function. And what R here is, R is basically a repository. So what we'll do is we'll come up here. We'll define repository. Okay. And the repository basically will be your database, GORM.db. So first let me import these packages, and things will start making a lot more sense to you. So here we'll say, firstly, obviously I need my github.com/go/fiber/v2. I need my fiber package. I need gorm.io/gorm. And I need go.environment. Because we've used go.environment out here, we'll have to import it. So I'll say github.com/joho/go.env. All right. Now all these links, they exist on GitHub, so you don't have to type these, right? You can just go to GitHub and just copy and paste these links. I'm typing it because in case if you want to type it, you can type along with me. Okay, so this is how you like we've imported these packages. And now what I want to tell you is that in func main, you'll have to define R first. Okay, So what you'll say is R is equal to repository, and the DB for repository will be DB. So you'll have to define DB as well. Right, so DB is a variable that we'll define shortly, which will be basically our database. But let me first tell you what's going on out here, right? So you might be confused, what's R, what's repository, what's happening out here. So repository is a struct that we have created on our own. Now structs are your own data types that you can create. So you have strings and integers and floats and all of those things with Golang. But while working with Golang, you also want to be able to create your own data types. And Golang gives you that ability. Golang says that you can use something called a struct to create your own data types. So I've created a repository, which is my own data type, and it basically has DB. Now DB is a pointer to gorm.db, which is GORM, right? And it has it gives me the ability to interact with my database. Now when I create repository here inside my func main, when I actually create the repository, which I am capturing in this variable called R, so that means R becomes a repository, right? So R becomes a struct of type repository, and it basically has DB, obviously, because whenever we instantiate R, which is of type repository, it needs to have DB, right? That's what the struct does, and the value we'll get from DB. That's what we need to work on. We need to work in this variable called DB, which has small d and small b, whereas DB, this variable that needs to have, has a large or capital D and capital B. And in our function setup routes, right, we send a app. But as you can see, the way we are calling this function is very different. We're saying r dot setup routes. Now r dot means that it's not simply a function, it's actually a method, a struct method. Struct method is like a function, but for those specific structs, so that you're able to access those structs inside that method, okay? So what I'll do is I'll create this method called setup routes, because it's going to be quite straightforward. So we'll say r star repository. So now you'll be able to easily access repository inside this function. So we'll say setup routes, and this function accepts fiber.app. Now this part, right, if this part was not there in this bracket r star repository, then that would mean that it's just a regular function. But just because this part is there, it now becomes a method, a struct method. And here I'll define a variable called API. I'll say app. Why app? Because app is something this function is getting from here, right? We're passing this app variable that we've created, which is an instance of fiber.neo. From func main, we're passing it here. We have access to it here, so we'll say app.group. That means all these APIs that we're going to talk about are belonging to the group /API. So all your APIs will start from /API. So we'll say api.post. You have create. Now I've taken the example of books because I want my viewers who have already worked on my MySQL and Golang video with me. I want them to feel at home here as well, so that you can relate, you can compare, and you can understand the differences that happen here with Postgres, which are not a lot, by the way. Not a lot of differences happen when we use Postgres. But Postgres is very, very common and I think popular, so that's why everybody wants to know how to work with Postgres using Golang. Okay, so you'll have a post method with this API, create books, but all of these will belong to the API group. So you'll have API/create books, right? And if you use post method, you will be able to call this method called create book. Now, as you can see, I didn't say function. So you're not calling a function called create book, you're actually calling a method called create book, because they'll all be repository methods or methods of type struct, which is repository. And here you'll also say api.get /get underscore books, comma /id, comma r.get book by id. Here you'll say api.get /books, comma r.get books. Okay. So now what I'll say is there are a couple of things I can do. but let me just work on this db variable for now. So I'll say db, the small db, right, will be equal to storage. Now we have not talked about what storage is, don't worry. And we'll have a function called new connection, which will basically take in your config, basically things from your config file, which is env. And here I'll have if error is not equal to nil. So this error here itself we're handling. So we'll say log.fatal could not load the database. Okay. So the storage, right? Storage is something that we'll worry about in a while. But before that, I want you guys to think about the book, right? On which everything, all the operations will be performed. So we'll define our book here. We'll say book as a struct. And the book struct has an author, has a title, has a publisher. And author is string, title again is string, publisher again is string. Now, one thing to note here is, as a confusion that a lot of people coming from JavaScript have with Golang, is that Golang basically does not understand JSON on its own. With JavaScript, you use JSON so much because JSON is JavaScript object notation that you start thinking that, oh, all languages understand JSON. But that's not the case. Only JavaScript understands JSON. So for Golang to be able to understand or work with JSON, you'll have to tell Golang as to what this variable is going to look like in JSON. So the way to do that is you'll say JSON, and this is going to look like this, author. So that means is that author has a small a, whereas the author that Golang knows and understands and is expecting has a capital A. So our job is to do something called as decoding. When we send a post request using our postman to Golang, we'll be sending information in JSON format. But with the help of decoding, we'll be able to get access to the struct, which Golang understands, and then we'll be able to work on that struct, right? Here again, we'll say JSON. And in JSON, this title looks like this, title with a small t. Similarly for publisher, this is what it looks like, publisher. Okay, now since we're using these third-party packages and we start getting these squiggly lines telling us that these packages don't exist, what we have to do is we have to go back to our terminal and basically say go mod tidy. And in the background, it'll start finding those packages and importing those packages for us. Now, there are obviously a lot more things that we have to do here. And I'm slightly pressed on time. So what I'll do is I'll have to keep this video. I'll have to leave this video here. And in the next video, we'll continue from where we left off. We have a few things more to do in main.go and a couple of, obviously, we have to create these two files. And we'll have to work on all these functions as well, the create book, delete book, and get book ID, all these 4 functions. Now, obviously, you need Postgres to be installed on your machine. I'll leave a link to the DigitalOcean article for installing Postgres in the description for this video. So in case you don't have it installed, we haven't reached the part where we'll start connecting our Golang with Postgres, but just as a note, if you don't have Postgres installed, you need it, and I'll put the link of the article in the description box. Okay. Now the second question somebody was asking me in comments yesterday. So it's good that I didn't upload this video in just one go, and I'm uploading it, in parts. So somebody asked me, that they use phpMyAdmin to work with MySQL. What interface am I using to work with Postgres? So I'm not using any interface. I'm just using the PSQL command line CLI that Postgres gives you. That's what you can use to create your table or whatever. Okay. Now coming back to Postgres. to the project, sorry. So coming back to the project, now we have created all these routes and these functions are not there. So that's why we're getting these squiggly lines out here. So we'll start creating these functions quickly. So we'll come up here for the create book function. So we'll say func create book. Now it's important to know that it's not just a function. Create book is going to be a struct method. So you'll say R and repository. Repository is the struct that you have defined here, which basically is going to help you talk to the database. And R is the initialized repository that we have created out here. So all of these struct methods will have access to R, which is our repository. And it takes in context, which is basically fiber.ctx. And this function is going to return errors. So you'll create a variable called book. Which is of type book, which is book is a struct out here. And we'll use context.body parser. So what's happening out here? What's context.body parser doing? Now, if you were using HTTP, let's say you're not using Fiber, you're using HTTP, you would have gotten access to the request, right? So you get access to W and R with HTTP package. So where R is the request. Now Fiber is a level of abstraction. In the background, it's obviously working with your response and your request only. And with the help of context, which fiber.context provides you, you get access to the body. And then you'll use body parser to convert whatever JSON that you're getting into book format. Now, like I said, Golang does not understand JSON on its own, right? So we have defined how the JSON is going to look like. And we have also defined the struct that Golang understands. Now we need a way to decode the JSON information into the struct that Golang understands. You can do that using the JSON encoding package, but you don't need to do it here because Fiber already has the ability to do that for you. So it gives you a level of abstraction, and people do get confused here. This is why I explained this. A lot of you would already be knowing this, and I don't have to explain it, but for people who don't know this and who will get confused out here, so I thought I'd just point it out that, this is what Fiber is doing. So we use all these frameworks like Fiber and Gen, and we think that they're doing a lot of magic, but they're not doing a lot of magic. They're basically a level of abstraction over things that you would have to do manually on your own anyways. So if error is not equal to nil, you will have context.status http.status unprocessable entity .json here in the JSON. I'll pass fiber.map message request failed. And you want to return the error. So again, you're using Fiber and you're using the map function to basically send a JSON request, right? And this name of the error is wrong. Now it's giving you a squiggly line here because obviously we don't have the HTTP package, so you can do that here. You can say net/HTTP. All right, so that issue has now gone away. Okay. So what you'll do now is, so now we'll obviously add it to the database. I'll come here, okay, and you'll say R, which is your repository, right? R is your repository. It has DB, so I want to access that DB. So I'll say r.db.create function and ampersand book.error. Okay, and here what we'll say is we'll capture this in a variable, in an error variable. We'll capture the error out here, and we can handle the error. So we'll say if error is not equal to nil, context.status http.status bad request. Okay, in the JSON you're going to say could not create the book, right? Because this is you trying to create a book using the database, and if you are not able to do it, you want to send an error saying that you were not able to, could not create book. Okay. And this bracket ends here. From here you'll return error, and out here you'll say context.status, http.status. Okay. So if everything goes well, there are no errors, right? We want to send a 200 error message. So not error message, 200 status. So here we'll say fiber.map, and message is going to be that book has been, I'll take it on the next line actually, it'll just look much neater. So I'll say book has been added. Okay, that's perfect. Now what you'll do here is you'll return nil. Why? Because we're supposed to be returning an error. Makes sense? It's supposed to be returning an error, and if everything has gone well, you will return nil from this function. Now comes the next function, which is get books. Guys, I'm little pressed on time. Okay, so I'm going to be able to just finish this next function, which is get books, quickly. So we'll say get books context star fiber dot. Now a lot of people ask me why I cannot make longer videos. It's because, guys, I upload videos every single day. So it's like a schedule, right? That I've scheduled. I create videos every day. But I run my own software companies, so I'm unable to provide more time than this. I try to do better, but this is the max that I'm able to pull out. But it's good to get something out rather than posting nothing. So that's why I do this. So I stay in touch with the technologies myself. Okay, so here what we're doing is we're creating a variable called book models, and it's a slice of type models.book. Now this is something that we have not worked on right now. It's going to be in our models package, so don't get confused with this as of now. Okay, what you need to be understanding is that we're still using our repository, using the database inside the repository to find all the books. So db.find. Okay, here we're saying book models dot error, and we can now handle this error. So we'll say if error is not equal to nil, we're going to say context dot status http dot status request dot json. Oops. So this is why I hate using extensions, but I use extensions for all the viewers, so that it's easier for you to understand, I guess. I mean, a lot of people have asked me to use extensions, that's why I use it. Otherwise, earlier I never used to use extensions. So could not get the books. Okay. So if there is an error, you want to say could not get the books, and you want to after this line, you want to return the error, because the getBooks function also returns an error, right? So if there's an error, you return an error while finding the books. But if everything went well, you want to say context.status. Obviously, you want to say http.status, okay, .json. And inside JSON, you'll have basically a fiber.map. And here you will have a message books fetched successfully. Yes. And then you will have your data, which should be equal to book models. And at the end, you want to return nil. Perfect. So what you're doing here is we have created a variable called book models, and that's what we want to find, book models. And book models is of type models.books. We haven't created our models package yet. That's why it's giving us a squiggly line. And we'll have to create that package. We'll have to import models package, and then we'll have to obviously have something called as books as a struct there. But here what we're doing is we're creating a slice of structs. We want to be able to basically send those books as data in as JSON, right, as response from this API. So this is why we had to create this variable, because that's what we want to send, right? Book models. It's basically a collection or a list of all the books there in your database. And you'll use repository database.find, and you'll find book models. If there's an error, you'll handle the error. If everything went well, you'll simply say 200, and you'll return the book models, and you'll send a message saying books fetched successfully. Now in the next video, we'll work on our getBookById function. We'll work on our deleteBook function. These two functions are remaining. And then we'll also quickly take care of our storage and models. Pretty straightforward. In the next video, I think we'll be done with this little project, right? So just wanted to create this project to show you how to work with Postgres, with Golang. And a few people have commented that they also want to see how PG-Go package works with Postgres. Fair enough, I'll create a video on that. And and one person has also commented that they'd like to see SQLC or SQL Boiler with this. Fair enough, I can show you that also, not a problem. We'll work with SQL Boiler. The only thing is that they get such a big layer of abstraction on your project that you don't understand where the problems happen. So this is why the first thing that I recommend learning is something like this, where you have to do a lot of work on your own with GORM. And then we'll work with something like SQL Boiler, which kind of takes away all the work away from you. It gives you a lot of abstraction. It's very easy to learn, but it's something that you should not start with as a developer who's starting out using Postgres for the first time with Golang. Okay, thanks a lot for watching. Do subscribe to this channel. I hope you're liking it. I put out awesome value every single day. So we'll just be working on this models file. So I will call it books.go. And this will obviously belong to package models, because that's how the Golang naming convention goes. The name of the folder is also the name of the package models. Package models. And when you import this package into your other files like main.go file, it'll be very easy because you'll be able to import the package directly. And this could have had multiple files, and all would have belonged to the package models. Okay, and we can import our package gorm.io/gorm. And here is where we'll define our books struct. It will have, what all can it have? It can have ID, and then it'll have an author, title, and a publisher. Now there are a few things that you need to look at. So one is obviously that you have to define this as integer, and everything else will be a string. Okay. And here, now I have the GORM documentation open with me. With GORM, what you can do is you can say something like this, GORM, and you can define your primary key. So you can say primary key, right? And there are many such things that you can do with this GORM keyword. So feel free to take a look at the GORM documentation and check out all the different type of keywords that you can use. So I'm using primary key here, but it's your homework to check out different types of other keys that you can set here, right? So just a hint, you can also set indexes on particular fields, right? So this is what the GORM keyword allows us to do. And there's one more thing that it allows us to do. We can also say auto increment, right, for the ID. In JSON now, it will appear like this, ID. Okay. Whereas author will appear like this, author. And title will be JSON title, and here it will be publisher. Got it. So in this database, right, when the database, the data is created, the ID will be created by the by GORM or by the database itself. Okay, these three other things, author, title, and publisher, is what we'll have to send. Right. This is why we mentioned auto increment, because the ID is something that will be created by GORM or the database. Because the first ID will be 1, then it will be second, third, and so on. Whereas author, title, and publisher is something that we have to provide when interacting with the API. Okay, and this is also the reason why this doesn't have a star, and these all are pointers. And then I'll need a function here for migrating. So GORM gives me the ability to auto migrate, in the sense with MongoDB you don't have to do this. With MongoDB, you're able to easily create databases, easily create connections and databases and all that. Whereas with Postgres, to start with, you need to have that database if you want to interact with it, right? It doesn't automatically create it. So you can use auto migrate function to do that. So the function that will contain the logic for auto migration will be called migrate books. And using this function, basically this function is the one that I can interact with from my other files. I'll pass db to it, which is of type gorm.db, right? Gorm being this package that we're talking about, and db being a variable or an argument to this function of type gorm.db. This function can return an error, and the main line here, the main thing that which is going to be the heart of this function, is basically db.auto-migrate. Now we already know that db is of type gorm, right? So gorm.db is something that we can access here, and that gives us, GORM gives us access to this function called auto-migrate. Feel free to check it out. I mean, I recommend that you check it out in the GORM documentation. It's a very common thing. I've used it in many other videos, like even with working with MySQL and all, we've used this auto-migrate function. Very commonly used with Postgres as well, right? Because you have to have that database to be able to talk to it. It's not like MongoDB where even if you don't have the database, you talk about the database and MongoDB will create it for you. With Postgres, you can't do that. You have to have that database. So this creates that database for you with, empty data. As you can see, it's an empty struct. Okay. Today we're talking about our storage folder or storage package. And here, let's call this file postgres.go. Now in our main.go file, we had a reference to storage, right? And this basically is going to have a function called new connection, which is responsible for creating the connection to the database. So storage folder, where it's called storage, and why this file is called Postgres, because it has all the logic to work with our Postgres database. Okay, so storage package is what we'll have to import out here. And we'll also have our config related logic out here. So let's do that. So let's call it package storage, and we'll import a couple of things. Okay, and for now at least I need fmt, and I obviously need, because this will have logic to work with Postgres, so I'll obviously need my Postgres. Let's say gorm.io/driver/Postgres. Now GORM has a lot of things, right? And amongst those things, it also has the driver for Postgres, and that's what we're using. gorm.io/gorm. Now there are many ways to work with Postgres, and I somehow find GORM to be the easiest and simplest way, and this is why I've shown this in this video. You can also use SQL Boiler to work with Postgres. You can also have PGGo, and I'll cover those in upcoming series, not as part of the series. This series only is going to have GORM, which in my opinion is the easiest way to work with Postgres. But in other series, I can also cover PGGo and SQL Boiler. Okay. Now your config. So config, it's going to have your host, going to have port, all common things, right? Host in the sense which, is it local host or is it on production? Port is like 8080 or 9000, wherever you want it to run. And password, user, db name, and SSL mode. So host is string, obviously. And all of them can be basically copied and pasted because all of them are strings. Now comes the most important thing, the new connection function, which we're waiting for. So we'll come here, we'll say func new connection takes in config. How do I know that? Because that's what I'm passing out here. I'm passing config out here. So that means if I'm passing out config out here, I have to also define my config variable. I'll do that soon. Okay. Takes in config. What is it? It's of type config. The struct that I've created. So config argument is basically of type config. And you have gorm.db, error. Okay. Let's take a variable called dsn. Let's say fmt.printf. And out here, I'll say host port, and then I have my password, my DB name, SSL mode, and yeah, so all these things, right? So for host, to be able to print it out, I'll have to say %s is equal to %s password, %s DB name, %s, and SSL mode. I'll put a comma here, and I'll basically print out these values, which are going to be corresponding to these. Okay, so I'll say config being the argument passed to me, which will have all of these values because it's of type star config, right, of the struct. So it'll have all these values. So it'll have a host, which will get printed out here, ahead of host, which will have config.port, config.user, config.password, config.db name, and config.ssl mode. All right. And after this, we'll have gorm.open, postgress.open dsn, comma, gorm.config. And here, you'll get access to your DB variable. So this function, the new connection function, basically returns DB, which is of type gorm.db. Okay. And here in our migrate books function, we had seen that this accepts an argument called DB, which is of type gorm.db, right? So the origination of everything is out here from the new connection function. Okay. This is what gives us access to gorm.db, the DB argument. And gorm.open function is basically responsible for creating the connection with Postgres. So this is like milestone 0. This is where it's all originating from. This is where you create the connection with Postgres. And how do you open or create the connection? You use all of these different things: your host, port, password, DB, SSL mode, etc., to create the connection. And now we can handle the errors. So we'll say if error is not equal to nil, we'll return db, error. And otherwise, if everything went well, we'll say db, so nil for the error and db, the value. All right. So only one small issue here is that is equal to sign. Okay, now this looks okay. We have to do a little bit of cleanup out here. So we need our config. Let's create config. So we'll say config variable is equal to &storage. Storage being our package that we just created in the last video. Storage.config. Config being the struct that we created in the previous video. And here we'll say we'll have to basically get the value of all the things. All the things being the host, port, and all of those things, right? So here we'll say host, and then we'll have our port. Okay, we'll have our password, our user, our SSL mode, and our DB name. So for host, we'll use the OS package get environment db_host. For here, we'll use our OS package again get environment db_port. For password, we'll use os.get environment db_password. And for user, we'll have again os.get environment db_user. And SSL mode os.get environment db_SSL mode. Here we'll have os.get environment db_name. So put the commas where it's pending, get the OS package, press save. Okay. So it's trying to save, and then I'm expecting it to be able to, as in all the extensions that I have now, they were able to get understand that models and storage are basically these packages that I'm talking about. I was going to do this manually, but it's good that the extensions did it for me. They were able to get the models and storage packages imported from the right places for me. Okay. To get rid of these quick lines quickly, what we can do is we can run go mod tidy, and we'll keep getting all those packages in the background. Okay, so you don't have to worry about it. What we have to worry about is in the main.go file, there need to be two more functions, which is the delete book and the get book by ID. So let's work on the delete book function quickly. So let's come here and say func delete book. Now we know it's not just a function, it's actually a struct method. So we'll have to say our repository. So we'll have access to the repository through R. Takes in context, which is of type fiber.cdx, and you will get back an error from here. So here we'll define a variable called book model, which is of type models.books, and we'll have an ID, which is context.params ID. Now the beauty with Fiber, right? So let me explain to you a little bit about that. So if you've seen my earlier videos where I've not used any framework like Gin or Fiber or G, I've just used the HTTP package, then you had to wrangle a lot or struggle a lot to get access to the params, right? It's not like you have to write a lot of stuff to access the params. Even though it's not complicated, but there's work involved, right? But with context, right, with Fiber, you get very easy access to params, which is basically ID params out here. And you get access to the request and response very easily. So that's basically, the Fiber package, or the framework, as they call it, the Fiber framework, in the background is just like a layer on top of your HTTP package. There's no magic going on, right? It's just giving a lot of abstraction to you, but at the back end, that's what it's all doing. It's basically converting your code to work with the HTTP package. Anyhow, here we'll check if ID is empty string. Right, so I use these frameworks like Fiber, Gin and all that, but I only use them because I know at the base level how to still build a program without using any frameworks. So if you want to be a really good Golang developer, you don't have to use all these third-party frameworks, and you should be able to build things just by using what Golang gives you. And that's when you'll understand things from a really deep level. So you'll say context.status http.status internal server error.json. You say fiber.map and here you will say message, the ID cannot be empty. Okay, so things like fiber.map, things like how to access the context, always have the fiber documentation open with you. So whenever I'm working with, let's say, something external like GORM or fiber, I always have the documentation open with me, right? I'm never am I flying blind. So that's a good practice. So always when you're building programs, don't try to guess, don't try to use your own mind, don't try to assume things, just open up the documentation and actually pick up stuff from there. It's not a problem. It's not a problem to pick up stuff from the documentation, okay? Then this delete method is, you have access to R, which is your repository, access to DB, and you will use the delete method. And you'll pass book model comma ID, ID being what you've received in this API. And let's handle the error. So if error.error is not equal to nil, we'll say context.status, http.status, bad request, and here you'll say fiber.map message would not delete book, comma, and here you'll return error.error. Okay, and then let's put context.status, http.status, okay dot. So if everything goes well, you can just send a successful message, something like this: book added, deleted successfully, and you return nil. Right, nil means the error, so there's no error, so we'll return nil for the error. Otherwise, we have been returning error till now everywhere. So book deleted successfully. And in this video, we are going to be working on our getBookById function. But before that, out here, we did write our migration function, migrate books, but we never called it. So we'll have to do that now. So we'll say error is equal to models dot migrate books, pass DB, DB basically being the new connection. So when you now look at this migrate books function, everything becomes clear because it's taking in DB, right? And DB was created here, which is the new connection, which is from this function, new connection. So you pass DB here and you handle the error. So you'll say if error is not equal to nil, you'll say log.fatal would not migrate DB. All right. So now the most important function, which is getBooksById. So come here above your setup routes function, and here you say func getBookById. Now, as you know, this is not simply a function; it is a struct method. So you have R, and then you have repository. This takes in context, which is of type fiber.ctx, returns an error. Okay. So, firstly, when we want to get a book by ID, obviously need the ID, and ID is going to come from context.params, as we have seen in the delete function. Okay. So with fiber context, you can easily access all the parameters. So you'll capture that in a variable called ID. Let's create book model. It's of type models.books. By models.books, we mean this struct out here. And we'll check if ID is an empty string, as in nothing was passed in the ID, then that means there's obviously a problem. So we'll say context.status http.status internal server error.json ampersand fiber.map, and your message will be ID cannot be empty. return nil. And you'll say fmt dot println the ID is comma ID. So whatever ID you've received, you're just checking. I'm just putting this line here to check, if the ID is received properly or what the ID is, just to be sure. It's completely optional, as in you can put comments here. You don't want to write this line, it's okay. But usually when I have an update function or a get book by ID function, I usually print out the ID so that I know that this function is receiving the ID and everything is working perfectly. So here you'll say r.db.where, so where ID is equal to question mark comma ID. You'll get that book. So it's a book model. So where ID is ID, the ID that you've received here in this function, then you get that book. Okay. And if error is not equal to nil, it's a context dot status http dot status bad request dot JSON. This is why I hate extensions, using those Golang extension guys, because it tries anything that I don't want to write. So you'll say fiber.map and you'll write the message. Could not get the book. And you'll return error. And here, if everything went well, there was no error, then you want to give a 200 status. So how do you give a 200 status? You say context.status and you say http.status okay dot JSON ampersand fiber.map, and here you'll say message book ID fetched successfully, comma data book model return nil. Okay, so that completes your main file as well. Now is the time to start running our program and seeing from Postman if any issues come up. Before we do that, I just realized that our env file is empty. So here I'll have to create my host similar to this host port password, and these variables need to be there in your environment file. So we'll have db host is equal to localhost and your db port. So your Postgres usually runs on 5432. So on my machine also it's running on 5432. You can check on your machine what it's running on. User is Akhil and db password is new password. This is my user and password that I've created on my Postgres. So in case you don't know how to do this, there's a very easy article on DigitalOcean on how to set up your Postgres, and then go to your Postgres terminal, which is PSQL, and then just creating a user with password. Very simple and straightforward. Then you have your db underscore name is equal to fiber demo and db underscore ssl mode is equal to this. So I've created this database as well, okay? And this collection or the table for books is created by MigrateBooks for me. But this database I've already created for myself, fiber demo. So I was trying to run the program with go run main.go and I got an issue, right? And that's because the issue that I can see why it's happening is because host and port, everything is okay, but password and the DB name is actually coming as new password, which is supposed to be my password. And SSL mode is coming as fiber demo, which is supposed to be my DB name. So there's a mix-up that's happening here, and I have kind of found the issue. It's because after host and port, it should have been by user, which is %s, and that's how the user will come. So it's host, port, user, password, DB name, and SSL mode. That's how it should have been. Now if we run our program, everything should be fine. So it takes a, as in it's running, as you can see, right? If it shows you this fiber on the screen, that means it's running. Okay, so make sure you see this fiber screen. And then we'll start now testing it on our Postman. So in our Postman, I have created create, get all, delete, and delete, get by ID already there, my requests. So for create request, it's post, and it's on localhost 8080, it's running. So as you can see here, it's running on 8080, okay? API/create books. Now I can send the name of anything. So here I've just written a very random thing, but let's say author is, I don't know. I'm just writing anything right now. And leave it. That's what just came to my mind. Title is the stream. Publisher is blah blah. So you send it, and it creates, it says book has been added. Now to see that book, you open up your get all, and you see that earlier when I was testing this program out, these books were added, and now this new book, Glenlivet, the stream, blah blah, has been added as well. And I know this is ID 8, so what I can do is I can get this by ID. So I'll just copy and paste it out here. And let's see what happens. Yeah, so it gets the right book for me, which is ID 8. Similarly for delete also, let me try and delete this book. So it says book deleted successfully, and when I get all, I will see that the 8th book, which is the Glenlivet book, it's not there. So all the APIs are working perfectly, and the code is working perfectly with Postgres. We've used Postgres, we've used Fiber, and everything works perfectly. And I'll put this code on GitHub as well. So if you have any issues somewhere, you can compare it with that. And I'm always there on LinkedIn, and you can connect with me, or you can put a comment on YouTube if you get lost somewhere. I can help you out. Thanks a lot for watching. Do subscribe to this channel because you get to see such awesome content, right? Nowhere else on YouTube you'll get awesome content like this. So thank you for watching, and I'll see you in the next video.
It's not a game, it's a rich thing.